Next, we'll look at separable differential equations. So any equation that can be written of the form g of y prime of t, equal to h of t, is known as separable. So the main idea here is the right-hand side will only involve t, the left-hand side will only involve y, in particular a function of y times its derivative. If we integrate both sides, this y prime of t dt, well, this is dy dt, dt, and you'll notice the dt's cancel, so that whole term becomes dy. So let's determine if these are separable. Here you'll notice there's a t squared on the left, however we could move it to the right by dividing. So now I have t plus 4 over y squared t to the 4th, or t squared, multiplying both sides by y squared, gives me y squared y prime, t plus 4 over t squared. So this is separable since we have a function involving y times y prime is equal to a function involving t. On the right-hand side, we could try to get the y's on the left-hand side by subtracting 2y. However, this is not separable, since this is not a function times y prime. Instead, it's y prime minus a function, and we do need the left-hand side to be a multiplication. So let's find this general solution. We can see that this involves a t, so it needs to be moved to the other side. So I have that y prime of t is 5 e to the minus 4t. We can then integrate y prime of t dt equal to the integral of 5 e to the minus 4t dt. Y prime dt just becomes dy. On the left-hand side, we still have 5 e to the minus 4t dt. The integral of dy is y, and on the left, I have negative 5 over 4 e to the minus 4t plus c. Next, let's try this one. I'll need to divide by x squared. In addition, I'll need to divide by y squared. I can then integrate. I now have y to the minus 2, and once again the y prime is going to become dy is equal to the integral of x to the negative 2 dx. So we add 1 to the exponent, and then divide by this number. And then the same thing on the right, plus c. We actually need to solve this for y. So I have 1 over y is equal to 1 over x minus c. I can then multiply both sides by y to get 1 equal to 1 over x minus c times y, and then divide by both sides. We'll go ahead and switch this back to x to the negative 1 minus c equal to y. So when we use this method, we do need to actually solve for y to get the final answer. Let's try solving an initial value problem. I'll first need to divide both sides by secant, and 1 over secant is cosine. We can then integrate. The y prime becomes a dy. And on the right we have cosine t dt. So I now have y equal to the integral of cosine, which is sine, plus c. I do have this initial condition. So when t is 0, this function should be equal to 1. Sine of 0 is 0, so I just have that 1 is equal to c. So y is equal to sine of t plus 1. One last example. We'll rewrite this as y prime of x is equal to e to the x e to the negative y. So I have e to the y prime of x is equal to e to the x. Integrating both sides, I have the integral of ey, and the y prime dx will become dy. And on the right-hand side, I have e to the x dx. So this leaves me with e to the y is equal to e to the x plus c. In order to solve for y, I need to take the natural log of both sides. So I have ln e to the x plus c. And I'll now use my initial condition. This should be equal to ln of 3 whenever x is equal to 0. So e to the 0 is 1. And in order for this to match, we'll see that we need c to be equal to 2. So on the right-hand side, I will also have ln of 3. So I have y is equal to ln of e to the x plus 2.